Number 17 asks us, what is the x-coordinate of the solution to the system of equations? So remember that all systems of equations have a solution written as a coordinate pair. If the system does not have a solution, then you would write no solution. If you have two of the same line, you have infinitely many solutions. But if you only have one solution, it is written as a coordinate pair. And this problem is asking us for the x-coordinate of that system. So I have 2x minus 7y equals negative 10 and 3x plus 2y equals 10. And the first thing I need to look for and see if I have a zero pair. 2x and 3x does not cancel out. Negative 7y and positive 2y does not cancel out. Because there is not an easy way for me to get from 2 to 3 or from 2 to 7, I know I'm going to have to multiply both of my equations. Just like I told you last time, the easiest thing to do if you don't know what to multiply by is to crisscross your coefficients. So because the bottom equation has a coefficient of 3, I'll multiply the top equation by 3. Since the top equation has a coefficient of 2, I'll multiply the bottom equation by 2. Because both of these are positive, I'll make one of them negative so that they cancel out. Negative 3 times 2x is negative 6x. Negative 3 times negative 7 is positive 21y. Negative 3 times negative 10 is positive 30. 2 times 3x is 6x. 2 times 2y is 4y. And 2 times 10 is 20. At this point, my x's cancel out. I have 21y plus 4y, which is 25y equals 30 plus 20, 50. Divide both sides by 25. Y equals 2. Again, they're asking me for my x-coordinate, but right now all I know is my y. To determine my x-coordinate, I'm going to plug it back into one of my equations. I'm going to use the bottom one. I have 3x plus 2 times 2 equals 10. I can simplify this to say 3x plus 4 equals 10, since 2 times 2 is 4. Subtract 4 from both sides. 3x equals 6. Divide both sides by 3. X equals 2. So because they're just asking me for my x-coordinate, the answer would be x equals 2. Number 18 we've looked at a couple times now. It says Tony's cross-country coach graphed data from a practice race. The x-axis represents the elapsed time and the y-axis represents the distance from the finish line. What does the x-intercept represent? So again, our x-intercept is where the line crosses our x-axis, which is this point right here. So we need to figure out what this 5 hours means. This line starts at 9. That means that Tony starts the race 9 miles from the finish line. As time goes on, he gets closer and closer and closer to the finish line until he reaches 0 miles from the finish line, or he is at the finish line. It takes him 5 hours to reach this point. So we're going to say it takes Tony 5 hours to finish the race. Number 19 asks, what is the solution to the system of equations? Again, we have two standard form equations, and I need to determine the point of intersection, or the time when these two equations are equal. So I can say that I have 4x plus 3y equals 3, 2x plus y equals negative 3. I do not have a zero pair. In order to create a zero pair, I can multiply this bottom equation by negative 2. When I multiply this bottom equation by negative 2, I'm going to get a negative 4x. Negative 2 times 2 is negative 4. Negative 4x will cancel out that 4x, and at that point I will have a zero pair. So 2 times negative 2 is negative 4x. Negative 2 times 1y is negative 2y. And negative 2 times negative 3 is positive 6. I'm going to rewrite my top equation directly below. So 4x plus 3y equals 3. At this point, I can add straight down. Negative 2y plus 3y is 1y. 6 plus 3 is 9. Divide both sides by 1, y equals 9. To solve for x, I'm going to plug it back into the original equation. 4x plus 3 times 9 equals 3. 4x plus 27 equals 3. 3 times 9 is 27, so I just simplified that out. Subtract 27 from both sides. I get 4x equals negative 24. Divide by 4. X equals negative 6. I write my solution as a coordinate pair, negative 6, comma 9. Number 20, we've done a couple times now. It says, what is an equation for this line? To write the equation, I need the slope and I need the y-intercept. The y-intercept is easy to find. It is where the equation crosses the y-axis, which is at this point. That point is 4. My m is my rise over run, so I can count between two perfect points, and on this graph I have several perfect points. And I'm always going to go from right to left. So I'm going to start at this point and move to this point here. I rise up 2, but each one of these increments are in 2. So really every time I rise 1, I'm going up 2 because it goes from 4 to 6 to 8. So up 2, up 4. So my rise is 4. My run is 1, but again I'm in increments of 2. So every time I go over 1, I'm actually increasing by 2. So my run is 2. 4 divided by 2 is 2. So this equation would be y equals 2x plus 4 because m is 2, b is 4, and this equation is y equals mx plus b. 21 asks us for the domain of this relation, and the domain is all of our x values. Remember I told you that domain and range are in alphabetical order the same way x and y are in alphabetical order. So because I'm looking for my x values, all I'm going to do is list out my x values that are given to me. They tell me that negative 4 is an x value, negative 2 is an x value, and 4 is an x value. Because this is not a function or a table, we do not know whether or not this is a complete line. We just have these points, and these are the x values associated with this function or this relation. Number 22 is another graphing question. This time they want us to graph the function y equals 2/3 x minus 4. To graph I need two things. I need my slope and my y-intercept. My slope is 2 over 3. And my y-intercept is negative 4. Remember to always include the sign in front of the number you're looking for. To graph this, I'm going to start at the point negative 4, and I'm going to go rise 2, run 3, rise 2, run 3, every time to the edges of my graph. At this point, I can connect these points with a straight line with arrows at the end, and this would be that function. We have one more page of the study guide, and I will see you in the final video.